normally distributed. So that's it for the PUD or LS model. Unfortunately, I couldn't share my screen again. We have some references. I think I will share the presentation on the group, on the WhatsApp group, guys. It's like sharing, then my net is misbehaving.
Okay, what about the model? What is the PUD model? How is it like?
Okay, so can I just say it out? The linear, the setup is we should have a balanced stationary model. When you say balanced, we're trying to say that the time frames or the time periods where we are observing the data on the observations, they have to be the same, and all observations, they have to have those time periods. So the linear formula regression model can be formulated as y. I wish I could write it, but it's y, then it, then it's go to beta 1 plus beta 2 xi t 2 plus up to beta k xi tk plus an error term which is I and t. That's the model.
Okay. Are you done?
Yeah, I'm done.
Class, questions? If you have any questions for this group, kindly ask some questions. If you have any clarity, subtractions, additions for this group. Any question, class?
I was on the WhatsApp group just now.
Okay. So we don't have questions.
Okay, I'm failing to type. So my question to you would be, what type of data can we use on the model that you have just presented to us? I understand. What type of data can we which is applicable on the model that was been presented? For example, I understand we have longitudinal, cross-sectional, and time series.
Okay. Tapio?
Okay. The type of data we can use is panel data, which is a combination of cross-sectional.
No, so Tapio, just hold on. Where are the other class? It's group 1, Tapio and Wales. Tapio and Wales.
Let me just check who is in here.
There's Courage, there's Evelyn, there's Edwin, Trusty, So, Yokai, Constantine, Kudakwashe, and Kasambi. Fellow group members, can you attend to this question? Not Tapiona. Do we have fellow group members here? Group 1 members, you're alone.
I think they're having network challenges.
Or network challenges?
Yes.
Oh, okay, so you can continue. Answer the question.
All right. Okay, so Tauraya was saying it is a combination. It's panel data, which is a combination of cross-sectional data and time series data. So, for example, I'll give you an example. We want the the type of feed that you give to cows on a farm are going to affect your milk yield over a period of time. So we're going to have maybe farm A, farm B, farm C, farm D, then each over 7 years. So you're looking at the quantity of feed or the type of feed that you're going to give to the cows, and the milk yield you're going to have over time on all those farms. That's an example that I can give you.
Okay, Taurai, I answered.
Yeah. Yes.
Okay. So, in terms of a pooled model, I'm referring to you, Taurai. In terms of the pooled model, you now use panel data. Do you attend the first lecture where we talked about all these types of data which you are going to use?
I was having network challenges. I couldn't even attempt to get into the lecture.
So unfortunate enough today, Tekwana came to your rescue. So whenever you try to fit a pooled model, just know that you are going to use panel data. The way you said it's a combination of the two, the time series data, which have got a time factor, as well as cross-sectional data, which have an individual factor. Okay, thank you, guys. Can I say guys in this case when there was just one person responding? So, what I say, Tapio?
Well, I want to say it was a team effort. It was a team effort. It's just unfortunate that there are network challenges, but it was a team effort.
Okay, thank you, Group 1. Let's have another group presenting. So for those, just select one guy who will be presenting, and then the others, maybe you can respond to any question which might have been asked, maybe on public chat, right? You might be having a network challenge, but in terms of writing some responses from questions, I think you can do that. Okay, thank you, Kapiwana and team. Group 2. Where's this guy? Group 2. If, where is your group 2? Who is presenting?
Mr. Makoche is presenting today.
Okay. It's now 10:51. I'm giving group 2 up to 11 o'clock. Mr. Makoche, we are waiting for you. Your time is ticking up. Is he online? Mr. Magoche?
Alessa,
Yeah.
can group 3 present while we wait for Mr. Magoche?
Are they ready?
Let me check with them.
In his absence, who else can present for group 2?
Let me check as well.
Yes, okay. If still waiting for you, you said group 3 are ready. Where are they?
Mr. Magoche is now coming in.
Okay.
Can you kindly share screen with him? Against Benjamin.
Okay, Benjamin. Benjamin. You said Benjamin is presenting.
Yes, sir.
Okay. Right. Benjamin is now a presenter. You can go ahead. Okay, Benjamin is facing network challenges. Who else is in that group can present? If you are having network challenges, then let's have another person presenting. You can't have network challenge the whole group. I want to believe that. If it's not Magoche, there's Samuel, there's Emmanuel, there's Karakati, Musesa. Can you have another presenter from that group?
Hello, sir.
Yeah.
Can you give me the sharing screen rise?
Okay. You are presenting for group 2.
Not really. Christy is going to present, but I'll share screen from this end. He's on mobile, so he can't share the screen.
Okay. Okay.
Hello, sir.
Yeah.
I'm failing to share my screen.
You are failing to share the screen.
Yes.
Okay. Let whoever is presenting just say out. Just presenting without sharing the screen. Okay.
Okay. Good morning. Can you hear me?
Loud and clear.
Okay, let me just look for the presentation. I'm on a mobile. Sorry about that. I was expecting to see it from. Okay. For group 2, my name is Chris. I'm presenting, and we are doing the fixed effects model. Okay. So the definition: fixed effects models are a class of statistical models in which the levels, that is, the values of independent variables, are assumed to be fixed or constant, and only the dependent variable changes in response to the levels of independent variables. So the variables are constant across individuals. These variables like age, sex, or ethnicity don't change or change at constant rate over time. So that's the definition. Okay. I'll go to the assumption, the fixed effect assumptions. Okay, the error is uncorrelated with all observations of the variable XX for the entity over time. If this assumption is violated, we face omitted value bias. So that's the first assumption. The second assumption ensures that variables are across entities. This does not require the observations to be uncorrelated within an entity. It's very difficult to try and say all the terms whilst you are not seeing the screen, but I'll try anyway. The XIT are allowed to be autocorrelated within entities. This is a common property of series data. The same is allowed for errors. UIT plausible in panel applications. The second assumption is justified if the entities are selected by symbol random sampling. And as for the formal model, sorry. Okay, maybe I can say it. YIT is equals to XIT beta plus AI plus UIT for T is equals to 1. So where YIT is the dependent variable observed for individual I at time T, XIT is the time variant 1 times K, that is the number of independent variables or regressor vector. Beta is the K times 1 matrix of parameters, and alpha I is the unobserved time invariant individual effect. For example, the innate ability for individuals or historical and institutional factors for countries. UIT is the error term. Sorry, are we still together? Hello?
Yes.
Okay, fine.
You are saying UIT is the error, is what? Is the error term, or what I say? What is UIT?
The error term.
Okay. What about
from the question I said YIT is equals to XIT beta plus alpha I plus UIT.
Okay. Are you done?
Application. No, I'm going. Application of the fixed asset model. One, staffing in hospitals and patient outcomes. These studies use traditional or else regression, where the unit of observation is the patient. The dependent variable is some outcome measure like mortality, a dummy variable that equals 1 if the patient died in the hospital, and the key predictor is staffing. For example, nurses per patient. It's also used in banking, securitization of global banking. Okay, estimation methods for fixed asset model. Fixed effects model control for or partial out the effects of time invariant variables within time invariant effects. This is true whether the variable is explicitly measured or not. Exactly how they do so varies by the statistical technique being used. Some of the methods used include.
You've got 2 minutes remaining.
Okay. Okay, sorry.
Can you kindly wrap up?
Sorry, that's fine. It's a bit difficult trying to use the mobile device sometimes, and it's a PowerPoint. Okay, limitations. Okay, I'll go to limitations of the model. Fixed effects limitation uses only data on individuals having multiple observations and estimates effects only for those variables that change across these observations. It assumes that the effects of unchanging unmeasured variables can be captured by time invariant individual specific dummy variables. Bias from measurement error is usually increased in fixed effects estimators, which may be why fixed effects estimates are usually smaller than those from cross-sectional data. And also problems can arise when fixed effects estimation is used with models containing a lagged dependent variable, although methods exist to deal with these problems. Okay, the last two. More limitations. They can't control for variables that vary over time, like income level or employment status. However, these variables can be induced in the model. Sorry, they can be included in the model by including dummy variables for time or space units. This may seem like a good idea, but the more the dummy variables you introduce, the more the noise in the model. And this could lead to over dampening of the model, reducing the usefulness as well as useful information. Sorry, I wasn't.
Okay, is time up for you?
Okay,
Questions,
fine.
class? Questions from class concerning the fixed effects model? The group guys are ready to vanish. Are ready to give you everything you want. Questions, guys? Subtractions, additions? Person is saying well presented. Okay. You don't have questions. So group 2, I heard the presenters talking something about a dummy variable, where you said you have to introduce in the model to. What is that dummy variable? And this question must be answered by some of the guys who not Christy. What are these dummy variables? Group 2. Oh, there's only one person in this group. Okay, Chris, can you chip in? I heard you saying something about dummy variables. What are they?
Hello, sir.
Yeah.
A dummy variable is a numerical value. Sorry, it's a numerical variable used in regression analysis to represent a subgroup of samples in a study. It's often used to distinguish the different treatments that can be given to a group. For example, you can use 0.1 dummy variable where a person is given a value of 0 if they are in control of a group, or probably 1 if they are treated in a group.
So can you have an example of a dummy variable? Okay, it's okay. let's have another group. You said don't have any other question. So let's have group 3. Group 3. I think by now all the other remaining groups are ready to present at any given time. Group 3 on random effects. Who is presenting?
Morning, sir. It's me, Christine.
No, it's Christine.
Yes.
Okay. Right. You can present.
Okay.
Christine, are you in group 3?
Yes.
What's your real name?
And it's like Christine Matanire.
Okay, all right. You can go ahead.
All right. Let me try to see if I can share my screen.
Kindly manage your background.
Okay.
Your time is ticking, Christine. You can start presenting.
Okay. Thank you, Say, and morning, everyone. I'm going to be discussing on. Let me try to move my screen. It seems as if I can't move my screen. Okay, can I start? I think I'm now on slide number 2.
You can go ahead.
Thank you. So the outline of my presentation is on random effects model, where we want to define what it is, the assumptions that are there, the application of the model, where it is used, and advantages of the model, disadvantages, the formula, and the differences between the fixed effects model and random effects model. Okay. Moving on straight to our definition, we are saying that random effects model, according to Wikipedia, it is also called variance components model, where it is a statistical model where the model parameters are random variables. It is a kind of hierarchical linear model which assumes that the data being analyzed are drawn from a hierarchy of different populations whose differences relate to that hierarchy. So in econometrics, right, random effects model are used in panel analysis of hierarchical or panel data, where one assumes no fixed effects. Here we're just saying it allows for individual effects to happen. So some of the assumptions that are embedded in this model, we are saying that, so for each possible level of the factor T might have a different effect. So here effect of level I is thus a random variable. Hence it has a certain distribution, right? And the distribution of effects, where we are saying one of our model assumption is that the distribution is normal, right? So our distribution will be normal in this case. So when we adjust that, it is necessary that we assume that the distribution of x has a mean of 0, and we call the variance of this distribution beta T2. The next assumption is effect of level I of T is called confusingly Ti. And the other one is saying, since the levels are randomly chosen, that is, we have a simple random sample of levels, we can say that the TIs are independent variables with the same distribution n 0 beta T2. So the conditions of the summation of it's the same in the previous models. They say that observations are independently taken within each level and between levels, and all have the same normal distribution. However, we also assume that the observations are made independently of choice of levels, hence the last condition. So I'm going to take you through the applicability of the random effects model, right? So it is applied widely in cohort survival and other hierarchical designs where individuals or groups are sampled repeatedly. So there is repetition that will be happening according to Natajaram and all those authors, right? So random effects can accommodate non-independent within groups, such as samples within individuals, right? Or individuals within populations. So some have incorporated random effects into resource selection, right? Or species distribution model in general. Ultimately, the application of the random effects, right, is to create a mixed or random effects model, all done to capture more realism in the system. Sorry for that. Where we are seeking to describe with our models, right? So in summation, we are saying that while all models are to some degree incorrect or inaccurate estimation of factor levels or pulling dissimilar information may extend the degree to which the models is inaccurate, thus making the results incorrect or even worse, remains misleading. So perhaps in summary, we can say it is clear to understand when you might not want to use random effects. You might not want to use random effects when your number of factor levels is very low. So here we are saying there is no firm rule as to what the minimum number of factor levels should be for random effects. And really you can use any factor that is 2 or more levels. So however, it is commonly reported that you may want 5 or more factor levels for a random effect in order to really benefit from what the random effect can really do for you. So another case in which you might not want to use random effects is when you don't want your factor levels to inform each other, or you don't assume that your factor levels come in a common distribution. So moving on the quick advantages that we derive from this. So the dimensionality constraint is greatly relaxed. So here we are saying even very large models can be estimated relatively quickly, or if we use this model, it allows inclusion of variables like GDP that vary in the same dimension as the random effects. And the last advantage we have is simple to estimate. We are saying a single dimension random effects model in strata when we are doing our imports, X, T, REG, in trade, in GDP, import, etc., as we can see here. And on disadvantages, we are saying that it relies on a strong assumption on multilateral resistance is normally distributed across countries with a given standard deviation. So that's one disadvantage. The AVW model tells us that multilateral resistance is important, but it doesn't tell us anything about its distribution. So in practice, we need to be comparing random effects and fixed effects estimates. So this is the formula that we derived from Panel Data Econometrics 2019, where we are saying that the function of YIT stroke IT CI is equals to F YIT Y head is IT plus that. So here in summary, we are saying that it is a non-linear model with a randomly distributed constant. We could take the idea of heterogeneous parameters to the parameters, right? And from utility-based multinomial choice model might naturally accommodate heterogeneity in marginal utilities over the attributed of the choices a random specification. So in summary, without wasting time, we are saying that the integral is over k over fewer dimensions, which makes quadrature unappealing. K, and the amount of tension needed to use a simulation is roughly linear in K. So a quick difference to note between the fixed effects model and the random effects model. When we look at the conceptual considerations with fixed effects model, we are saying that estimate effects in this sample of studies assumes effects are same in all studies. So there is similarity happening here. And then in the random effects model, we are saying estimates effects in a population of studies from which the available studies are random sample, right? And that it assumes effects differ across studies and put mean effect. When you look at statistical considerations with fixed model, variance is only derived from within study variance, whereas in random effects model, variance is derived from both within study and between study variances. Then on practical considerations, narrow CI, we are saying that large studies have much more weight than small studies when we are using fixed effects model. And on random effects model, there's wider CI, where we are saying larger studies have more weight than smaller studies, but the gradient is smaller than in fixed effects model. So in summary, that is what we had as group 3. Thank you.
Okay, questions from class? Do you have questions from class? Group 3 is presented. So thank you, Group 3, for reading out the presentation. But on your model, why did you choose such a complicated model? Christine, on your slide number 8, the model you chose to is something, is very much complicated. You can't even say it out, isn't it?
Yeah, that's true. I think we're still researching. I think we could find a simpler one.
Even a simpler model is all over. That random effects model is not that complicated as you like the one you just presented. Okay. All right. Thank you for the presentation. If there are no any other questions, Taurai is saying something. Are you part of the group?
Oh, yes, I'm part of the group.
Why didn't you use that one during your presentation?
We wanted to explore the other options. We thought this one would not be sufficient enough.
Okay. All right, thank you. So let's have group 4. Who is presenting group 4?
Morning, say, can you give me the rights to present? To share my presentation?
Sheila. Where is Sheila?
Yes, it's Theodora Sheila.
Okay. You can start presenting. Sheila, we're waiting for you. Are you having any challenges? Sheila, we are running out of time. Start presenting.
Say, sorry, I'm failing to share the screen.
Okay, go ahead. Just go ahead without sharing the screen. Are you group 4?
Yes, group 4.
What's your name?
Theodora Sheila Capado.
Capado.
Yes.
Okay. What was your question like?
I was supposed to present about the Pagan test. So I'll start presenting the Pagan test. Can you hear me?
Yes, you can go ahead.
Okay. The Pagan test is a statistical test that is used to determine whether or not heteroskedasticity is present in regression model. I'll define what heteroskedasticity is. This is a phenomenon where the variance of the residuals is a non-constant. Thus, the standard deviations of the predictable variables change over a range of measured values. heteroskedasticity violates one of the assumptions of linear regression, which states that residuals are equally distributed among the independent variables. This is according to R. Carter 2011. The effects of heteroskedasticity on regression model are that as the result of the regression and
Okay, Sheila. Remember this Pagan case. Hello, Sheila. Remember, you are presenting a Pagan case in the sense of a panel data model, isn't it? Okay, you can go ahead. Where is Sheila? You can go ahead. Whoever is presenting, you're taking too much time.
Hello, sir.
Okay.
Sheila is saying she lost out. She's having network problems.
What about the other guys? Is she alone in the group?
She's saying Tendai can help.
Yes, Tendai. Where is she? Is Tendai male or female?
I lost my network. I don't know if Tendai can help me, or I can try again. Tendai, can you help? Can I start again, sir?
Go ahead.
I thought you had asked something. I don't know. Whilst I was presenting.
I was saying, remember the Pagan test, you must present it in the sense of panel data models. I heard you saying more under the normal regression. Okay, you can go ahead.
Presenting, then maybe the group members can help me with the questions or
just
your
present whatever you
expectation.
have. Just present whatever you have.
I was on null hypothesis. Homoskedasticity is not present. Thus the residuals are distributed with constant variance among the independent variables. When we have alternative hypothesis H1, homoskedasticity is present, thus the residuals are not distributed with constant variables, with variance among the independent variables. The steps to perform the Pagan test, the following are the steps. The first one is to fit the regression model. The second one, calculate the squared residuals for the model. The third one, fit a new regression model using the squared residuals as the dependent variable. The fourth one is to calculate the chi-square test static x squared and n r squared mu, where n is the total number of observations, r squared mu is the r squared of the new regression model that used the squared residuals as the responsive value. The result of the which a corresponding p-value with a corresponding p-value. The common choices of threshold degrees of freedom for the p-value are 0.01 and 0.05 and 0.10. For example, using 0.05 degrees of freedom, if p-value is less than 0.05, we reject the null hypothesis and conclude that heteroskedasticity is present. If p-value is greater than 0.05,
Sheila, are you saying 0.05 degrees of freedom? Did I get you correct? Saying 0.05 degrees of freedom.
Sorry,
0.05.
Sorry, Sheila. Is it possible for you to share what you're presenting so that we can also read what you're reading as well?
Okay, but I was failing to share. I was saying 0.05 confidence interval.
Okay, it's okay.
Okay. So if the p-value is less than 0.05, we reject now hypothesis and conclude that heteroskedasticity is present. If the p-value is greater than 0.05, we then accept the null hypothesis and conclude that heteroskedasticity is. So there's an example, but this one I need to share the screen. Maybe the others will see. Data, viewing data. For example, after performing multiple linear regression, we can perform the Pagan test using the Heteroskedasticity test. The results from the example, which says that H0 is the null hypothesis of the test, and the residuals are distributed with constant variance among the independent variables. Then a variable is the independent variable that was used in the regression model. Chi square is the chi-square statistic, which was 14.78 from the example, and the probability is greater than the chi-square. The p-value that corresponds to the chi-square test statistic in this case was 0.0001. So since the p-value was less than 0.05, we had to reject the null hypothesis and conclude that heteroskedasticity is present in the data. If we fail to reject the null hypothesis of the Pagan test, we can conclude there's no heteroskedasticity in the data, and we continue to interpret the result of the original regression. So in the example, we rejected the null hypothesis, hence the standard errors that are shown in the results are not reliable. There are certain ways to fix heteroskedasticity, which are first one, transform the dependent variable. This can be done by using the log or square root of the dependent variable. For example, log price instead of raw price. Taking the log or square root of the dependent variable will be an effective way of fixing heteroskedasticity data, the dependent variable, which can be used to fix heteroskedasticity. For example, you can use a rate for the dependent variable rather than the raw value. The example is if you want to predict the number of Econet shops in a city and we are using the population size, which is the independent variable, to predict the number of shops, which is the dependent variable. If we discover heteroskedasticity in the data, we can, instead of using the population size to predict the number of Econet shops, we then use the population size to predict the number of Econet shops per capita.
Okay, Sheila.
That's all I have.
Okay, thank you. Any questions, class?
I'll share the presentation maybe in the WhatsApp group.
So, guys, let's be particular about certain terms, like the 0.05. This group was saying is a confidence interval. A confidence interval is a range of values where you say, remember, in our yesterday lecture, we said a confidence interval is given. It's a range from, say, if the coefficient maybe is 2, the confidence interval runs from the left-hand side to the right-hand side. That's a confidence interval. That alpha, which by default is normally 0.05, is not the confidence interval, it's the significance level of significance. Right? So you have to correct on that. Just revisit your notes. Make sure that you say out things the right way. Okay. So the last group.
Those presenting, tokumroga mutange mashare kana musuru kwanisa ku present. Kindly share my WhatsApp group so that you know follow as you go.
Okay. Group 5. Who is presenting from group 5? And here's someone presenting from group 5, guys. Time is not on our side. No presenters on group 5.
Group 5 itaika plan au mana nguva dzekutobaya makangonyarara vanwenyu ngangotanga kutaura.
Okay, Michael, you can start present. You can be presenting. Thank you.
I say,
Yes, you can start presenting.
all right.
What's your name?
Michael
who?
Michael is here.
Michael says, okay, thank you. You can be presenting.
All right. I'm trying to share my screen.
If you are having challenges sharing the screen, simply share with the others on your groups, either on WhatsApp or whatever, so that they can be following while you are presenting.
Okay, yeah. I'm sharing in the WhatsApp group. So we are presenting on the test for choosing between models, the Houseman test. So this one, the Houseman test, it is also called the Houseman specification test. It detects predictor variables in a regression model. So these predictor variables are values that are determined by other variables in the system. So having these predictor variables in a model will cause ordinary least squares estimators to fail. As one of the assumptions is that there is no correlation between a predictor variable and the error term. So the instrumental variable estimators can be used as an alternative in this case. However, before you can decide on the best regression method, you first have to figure out if your predictor variables are endogenous. This is what the Houseman test will do. So this test is also called the Debbin-Wu-Houseman test or the Augmented regression test. So this one is used in panel data analysis as a test model for misspecification. So in this panel data analysis, which is the analysis of data over time, the Houseman test can help to choose between fixed effects model or random effects model. So the now hypothesis is that the preferred model is random effects. And the alternate hypothesis is that the model is fixed effects. So essentially, the test looks to see if there's a correlation between the unique errors and the regressors in the model. The now hypothesis is that there is no correlation between the two. So I'm going to just give a brief explanation of the random effect and the fixed effect. So there are two ways to estimate a regression model with error terms that are assumed to consist of several error components. The first is to estimate what is called a fixed effects model, and the second is to estimate what is called a random effects model. In a fixed effects model, each equation is constant, is a separate parameter, and values are potentially correlated with other regressors. But in a random effects model, the difference in the VI are randomly distributed between units and are necessarily uncorrelated with other regressors. So these two approaches, the random effect and the fixed effect, they are conceptually quite different. So for the random effects, as this approach, it is just more appropriate if observations are representatives of a sample rather than the whole population. So in random effects, we assume for us, we have to construct an efficient estimate. We have to evaluate the structure of the error and then apply an appropriate generalized least squares estimate to find an efficient estimate. So unfortunately, there are equations which are there. So the random effects estimator is the standard generalized least squares form summed over all individuals on the data set. Then going on to the fixed effects. So the fixed effects estimator can also be written in GLS form, which brings out its relationship to the RE estimator. So it is given by the equation which is there, but unfortunately, I think you will see it when I share the screen. So pre-multiplying a data matrix X by M is the effect of constructing a new matrix comprised of deviations from the individual means. So this is just a more elegant way mathematically to carry out the operation we described previously. Then I'll go on to denote the relationship between the random and the fixed effects. So the random effects estimator is a weighted combination of the within and between estimators. So then for the Houseman test, if there is no correlation between regressors and effects, then FE and RE are both consistent, but FE is inefficient. Then if there is correlation, FE is consistent and RE is inconsistent. So under the now hypothesis of no correlation, there should be no difference between the estimators. So that's all we have for the tests for choosing between the models on the Houseman test.
Okay. Any questions, class? Do we have any questions? If there are no questions, then we can have a smoke break of how many minutes? Suggestions. Smoke break of how many minutes?
Let's do even 5 minutes so that at least we push and finish a bit early.
Someone saying 10 minutes. This guy is saying 5 minutes. So
I support the previous speaker. What time are we ending the lecture? We can just do a short break, then we
because from now, I wanted to present something on the practicals. I want to have 2 practicals done today. So if we make it 10 minutes, right? 10 minutes to come back and do the practical. So in the meantime, I will send you the do file so that you can be cruising. You see, don't want to waste time today because now that we know how to import data and all those other commands, we're not going to take time on this time around. Okay, so let's have 10 minutes. So at 10 past 12, we'll be back. Thank you.
Related with the term